all right, so in the old days, now you understand what I'm talking about. So in the old days, our life was much simpler. And today, when we think about systems, it's much more complicated, right? You've seen the change of slide, correct?
Yes.
Oh, perfect. Thank you. Okay, so I'll assume that
Yeah,
it's
correct.
correct from now on. So again, everything is much more complicated. And there is even a field in the academics is talking about complexity in different sciences. There is even a proof that our world is becoming more and more complicated. Now, again, we talked about how organizations are handling these kind of issues, how they're handling this kind of complexity, and why do we have security issues. If you remember, on one thing, we talked about budget. On the other side, we talked about manpower. We also talked about what technology can give you, right? We talked about how you can use technology, but technology has a certain limit. I mean, it's up to a certain point that technology can help you with managing security issues. And also we talked about some breaches that we had. Of course, the famous one is JP Morgan that I explained, but we also have others. We had eBay, we had Equifax, we had Target, Home Depot, MySpace, and so on. All of them had millions of dollars installed in security, but all of them were breached because of misconfiguration, application security, outdated components. And in the end, it goes down to how we structure our systems, okay? So today we're going to talk more about what is the right way to really secure your system. And I'm coming from one specific angle. And I think that today you could be a part of the problem or part of the solution. There is no more neutrality in the world, okay? So when it comes down to application security, all we need is one person, one vulnerability, one weak link, that from there on, we can basically get inside the organization. And I also said before that if you look about cybersecurity experts, if you talk about your security department, basically what they do is they gather information about threats. This is what they do every day. They get up in the morning. Second, let me just add a very cool laser, right? This is the laser, okay. So basically they get up in the morning, they do what we call a cyber threat intelligence. They are gathering threats and new vulnerabilities that they hear about. They're trying to risk assess whether this vulnerability is related to a lot in any way, right? They create an action plan and then they should handle that. But I already explained before that developers are not cybersecurity specialists. They shouldn't be. They have their own profession, and development is a huge profession. You should do quite the opposite. And if you remember, I said that Microsoft came with the idea that if you want to get into the building, you should ask the security guard. You should ask the person that is working there. And the same thing, if you want to know how to break the application, if you want to know how to get in, you should ask your developers. And when they said that, they created what we call a cyber threat modeling. I'm not going to go into the tools, I'll just explain the concept, but the concept is basically you understand the application, break the application down, try to think about how an attacker can try to abuse it, what is not working well, what kind of sensitive actions you are not alerting on, okay? Try to think like a hacker. And then after you identify the threat, try to see whether you're correct. And in some cases, you can do that. In some cases, you can actually break the application. Of course, if you are planning to do something that will break the system, please try to tell someone that and ask for permission to do it, because there are some security tools like the ones that we will show you in the lab, those that will register for the lab. There are security tools that can break your database or can break your infrastructure. For example, we have fuzzing tools. Okay, fuzzing tools. Anybody knows what fuzzing tools are? Fuzzing? No? Okay. So fuzzing tools are tools that have hundreds of thousands of inputs in their databases, and basically you give them a form and they just overload it with information. So if you have a form, let's just say you have a reservation or an order form, and you want to test it. Okay, so you yourself will probably do it once or twice or 10, and you will give it to a very dedicated QA, and he will do it 100 of times, right? But you have tools that can do it hundreds of thousands of times for you. and they can try to create fake information, enter it, and fill the forms in a fake way. Now, on one hand, it will tell you what kind of vulnerabilities you have on that form. But on the other hand, you will have a lot of fake information inside, right? So basically, you are destroying the database, correct? So again, tools are important. When you try to do it, just keep in mind that you need to tell someone, okay? Or do it on a test environment or something like that. All right. So again, if I'm comparing what cybersecurity specialists are supposed to do in compared to developers, it's completely different, okay? Because in the short term, people that are working in development are doing something which is proactive. You want to try to think how it can be abused, right? So you're doing it before it was attacked, while your security department is reactive. It's reacting to threats. Only when something is happening, they are trying to fix it. But you can try to think about issues before it happens. You can find issues. Cybersecurity is finding attackers, okay? So basically, you can train yourself, you can learn how to become better developers, and in the end, you can find issues. Unlike cybersecurity specialists who are basically using feeds and tools and so on, and try to see how that is connecting to them, okay? If I'm going too fast, you will stop me, right? That's the deal. All right. So the first rule in creating an application, in application security procedures, what is the first rule that you need to make sure that you are doing? What is the first thing? What is the first rule of application security? No? Let me see if everybody are here. Okay. So basically, I see that no one will tell me. Okay. So the first rule is basically use application security principles that are created by developers for developers. Okay. We have a lot of policies in the organization, but when it comes down to development, you need to use the best practices of the languages that you have, right? You need to be able to use the languages best practices of Angular, of Java or .NET and so on. And you need to take these best practices from a source that was built by developers. For example, OAS that I gave you before, if you remember, I said that you have 42,000 people with it, right? 42,000 developers that are working, not working, volunteering over there, that they created best practices. And I even showed you one of them, the OAS ASVAS, that maybe some of you went in and saw that they are showing you very practical tips about how to work secure. So this is basically the first rule. And again, the second rule is that you cannot do everything. Okay? Even when we talk about application security, we should limit our efforts to something which is practical. Okay? So again, you can do anything, but not everything. So the second rule is you need to have certain levels of protection. Okay? So one, you need to have the rules created by developers. And two, you need to have a certain understanding that yes, we cannot test everything until the end of time. There is a certain limit, but we need to define these limits. Okay, so we need to create some sort of circles about how we want to secure our system. For example, we have the minimum level of requirement for all the application. Even if the application is not critical, we will have still a certain level of protection. On the second phase, of course, for sensitive data, we will have a second phase, and for critical assets, we will also have a third one, and over there, we will have a lot more efforts than in the first level. This is, of course, coming also from your customers. Some customers have more strict requirements than other customers, right? So you need to have certain levels, because in the end, we need to divide our efforts. Now, if you take this approach and you're looking at it in a practical way, you can take it directly, for example, to testing, okay? So, for example, when I'm doing a test, I can look at unit test, right? So this is the very limited type of test that I'm doing. I am doing a very accurate, specific test to check a certain change that I made, right? This is the first one. We can also take it to the next level. The next level, of course, is integration test, trying to understand how my change affect other models, correct? So, okay, so I'm checking the connection between different models. I'm writing maybe scenarios in Selenium and so on, using other automation tools, seeing that my change doesn't affect other areas in the application and so on. And the last one is, of course, system test, which is a complete test. Now, think about it. It doesn't make sense for every change to do all these kind of tests. Practically, we don't have the time. Second, we don't have the budget and no one will approve us. And then versions will be something like once a year. And even then we won't be able to do that. So we need to divide our efforts on how we are working. And we need to understand that we cannot do anything. Because like I said, application security is something that should be practical, something that we should be connected to our actual job. And if it will be something that is not, then no one will follow it basically, okay? So now this is the first rule and the second rule. Now I want to talk about the third rule and I want you to come up with it, okay? So let's continue to the next one and I'll give you a scenario and I want you to tell me what is the rule that you think, what is the first question that you should ask, okay? So my scenario is this. Our company wants to create a one-time invitation link. Okay, someone will get the link like in the picture, and then he can invite his friends to somewhere. So the question is, what kind of security do you do over there? And other than that, what is the first question that you need to ask? Go for it, write it down. Diego, do you see the slide? Do you see the white slide of rule number 3?
Yes, I see the test.
Okay, sorry. So I will try to be slower next time. So I'm asking again, how do you secure this link? How do you manage security for that? Okay, I want you to try.
HTTPS, SSL.
HTTPS. Okay, so we're saying the first, we want to encrypt the link, so it will be, we will have a secure tunnel. Okay, perfect. That's the first one. What else? Latest version. Okay, latest version of the TLS. Okay, good.
We have to make sure that the value after the .com/ not incremental.
Brilliant, you're right. So we need to make sure that no one is able just, to start hitting us and denying service of us and just try to generate the link that we know. Okay, so that's true, guy. Exactly, you're thinking right. Next.
Limit connection.
Oh, limit connection. How many times can I click? Can I hit the link? Okay, but what's okay? Rate limit. Yeah, oh, right. Okay, so Philip is also an excellent hacker. So I'm asking, what is the first question that you should ask yourself?
Do we need it?
Do we need it? I hope if it got what I have to lose. No, hopefully if you got that task. So like I said, you get it as a fact in the task. Okay, so is it a legitimate invitation? Wow. Okay. So yeah, you need to check it. Does this link come from our company and not the hacker? Perfect. Okay. So I will say that when I did the scenario, your assumption should have been that the company wants it. But okay, let me tell you what is the first question that I'm asking myself when I'm presented with a scenario referring in application development. I am asking myself, how do you call it? What is the name? What is the professional name for links that are activating something? Okay, how do I call it? I mean, if I know how it's called, then I can Google it, right? So anybody knows how do you call these links? Hyperlink, no. Hyperlink is, you're right that it's a hyperlink, but how do we call links that are actually doing an action in applications? How do you call that? Ideas?
Engagement links?
Engagement links, no, but I love the names. Deep links, no. API, no. You need to call the child by its name, right? Because you want to search for best practices. Because, you know, I sent you, for example, to OWASP, right? OWASP have tons of pages. I mean, you need to know what you're searching for, okay? So I had a company that came to me with this request. So I told them, why don't you search for best practices on capability links, okay? And then they said, what? I said, capability links, okay? Capability links, and you have a lot of information on capability links. Capability links is basically a link that is doing an action, right? So capability URLs are basically giving you best practices that you can use in your development, right? For example, they should expire, okay? For example, they need not be, like you said, guessable. They need to be unique, use HTTPS. They should include, for example, the pages that they open shouldn't link to another page because I don't know who got the link, right? Google shouldn't index this link, right? You shouldn't index it or include it in any other environment. And of course, if you write down capability links with your programming language, you will get also best practices on how to implement that. Of course, they bring other challenges, right? How do you identify the person that click on the link? How do you
Can
do
you
that?
explain the capability? I didn't understand. Why it need capability URLs? This is something...
Why it's called
I didn't
capability
understand.
URLs?
Yeah.
Capability URLs, that's the name for URLs that are creating an action that grant you access to a resource. That's the professional name. So if you're creating such links, if you know the name of that, if you know the name of the technology that you are searching for, if you know the term that you are searching, then you can search for best practices. Of course, like Philip said, you do have other options. All I'm saying is the third rule is that if you can not reinvent the wheel, but use best practices, then it's much easier for you to work. So the third rule is know what you need to work on. Know what you are searching, okay? And if you know how it's being called, then you can have a better work. Then you can use the best practices that other people already did the job and researched it, okay? So questions about the third rule? You're good, right? All right. So, okay, so when we talk about secure coding practices, and I'm trying to gather also from various sources, it always starts with input validation, output encoding, authentication, password management, everything that is related to access control, or if you're looking for the vulnerability side, we're talking about broken access control. Of course, we have error handling and logging. Error handling is how we expose the error, for example, to other people, how we retrieve information to us that helps us in identifying issues inside the application, like sensitive actions that are being done on the application, or even someone that's trying to manipulate. If you remember the Polar case that I gave you last time, right? And of course, the basic checklist is handling how we protect sensitive information. But if you look at OWASP, for example, you will see that they have, a much advanced one. And I know that for some of you, it will look obvious and not really advanced, but again, it is. I mean, like cryptographic, like database security, communication, session management, things that are really more related to the architecture, file management, memory management, and of course, a lot of good practices over there. But the first thing will basically always come from how we can really try to find out what we are looking for in the amount of data that we have. I mean, you all know how to Google, right? But the problem is trying to find reliable sources that will give you good answers, best practice, practical answers. And you do have those. For example, in OWASP, last time I introduced, we do have, for example, the top 10 proactive controls. You do have that. And for example, in Israel, when you look at the government standards and so on, so when you have requirements from a government agency, they ask you to be compliant with the OWASP top 10. And when you look at the proactive controls, I'm sure that all the top 10 here will not be a surprise to you. I'm sure that all of them are somehow connected to your work. For example, the first one is understanding what are the security requirements, leveraging framework and libraries that already exist and not try to introduce new components, trying to use the security frameworks that we already have, securing the database access, of course, not exposing the passwords to the database, and also using C3 also talks about what kind of permissions we need to give to that user who is being able to access database. Of course, we have to encode and escape the data so that the user or we, when we get the information, we will not try to refer to it as a command. We have number 5, which is validating all the inputs, which in the past, if you remember, in the past, we sometimes said that the server is considered to be a safe zone and that the internal network is considered to be a safe zone. We'll talk about input validation a bit more later, but today there is no safe zone. We do not believe that the inside of our network is secured. We'll talk about digital identity and also enforcement of access control, protection of data everywhere, because as a supplier, it's your job. Logging and monitoring, if you remember the target case from last week, this is exactly this, when organization receives the alert but doesn't really know what to do, or when organization sends all the alerts by email, right? So this is something that you cannot work with when you have thousands of errors and so on. And of course, how you handle exceptions and so on. So today we are going to talk about checklists and what you need to know about checklists. What you need to know if you prepare yourself for checklist is that checklists are supposed to be simple. They are supposed to be straightforward. They are supposed to be related to the programming language that you are working with. You should not attempt to rank it, whether it's high, low risk, high risk, and so on. It should be easy reference for you to work with, and it should be something that you can actually work or apply if you need it in your day-to-day job, because it couldn't be 70 pages, right? It needs to be something clear and so, and this task was already handled by a lot of suppliers that give you policies for secure software development. So what I have here in the next of our session, I want to talk about best practices about secure development. These best practices are taken from organizations like OWASP or SafeCode and others that basically give you these instructions. So I want us to try to take these instructions, try to break them down, try to explain them a little bit more. I'm sure that you can relate to most of the things that I'm saying here. All right. So the first one, the first best practice that you want to take is related to input, right? So input, we talk about input validation. What is input validation? I'm sure all of you are doing it in some level. So input validation is
usually the structure.
The structure.
Usually.
Okay, so we validate the structure of the information that we get. Okay, I get it. If we can agree, schema-based validation, perfect. This is, for example, for XML and also for other type of information. Brilliant. Okay, so input validation, as you said, we assume that anything which is external to our application is evil. This is the bottom line, right? We assume that someone is trying to attack us. We assume that our users are making mistakes, even if they are not malicious. We assume that, and we want to make sure that the input validation is done before we are doing anything, before we are processing. Where should we do input validation? Client or server? Where do we do that?
Both at the client and the server side.
Oh, but let me ask you this. Why do we do it on the client side? Why do we do it on the client side?
So that it doesn't get modified by any bad guy?
Well, on the client, you can modify whatever you want. The client is the client side. This is why you call it the client side. It's over there. So the data on the client is malicious by definition. It can be controlled completely by the client. Okay. So I'm asking, why do we want to do it on the, and already I see in the chat that people are writing, but on the client, tell me.
So it doesn't, the client data doesn't modify the database and extract information out of it.
I'll say that on the client side, you cannot do it. On the server side, I agree. But on the client side, from all the reasons that they said over here, this is true. If we want to save unnecessary requests to the server, for example, if he's entering the email and we don't want him to go back and forth, okay? If we want to have better user experience, right? So if we want to have better user experience, we will do it also on the client. But on the server side, it's mandatory to have all the checks. On the client side, you can do it, but know the reasons. You want to save traffic to the server, or you want to have a better user experience so that your customer will not need to wait. But in the immediate term, you need to know that on the client side, if you need not to check something, it's better not to check it on the client side and keep it on the server side. You always check it on the server side, okay? And you all answered on the chat. I saw the answers. You're all perfect. Thanks. So if we want to summarize this point, so we should validate all data that we receive from all sources, okay? We want to do it as soon as possible. I mean, if we do have several functions that are basically talking to each other, I don't want malicious input to go deep into the application. We should do input validation before the data is being processed. We should try to find if some of the information is malicious or malformed and so on. If it's not, like you said, the pattern that I was searching, if it's not the type that I looked for, okay? So if you see that, again, I want it to be done at first. Now, if some of the information is incorrect, I don't want to process it. If some of the information that I'm getting from the customer is not working, I don't want to have half operation. I want to have a complete operation. And I want to start checking the information before it is before it's going down the different functions in the application. All right. Now, so that I think is okay. Now, so we talked about SQL injection in the previous session. So we do have, for example, this kind of injection that could be very easily solved with input validation, right? This is from 2019. This is Globus Max, an Israeli cinema website for movies. And of course, you can see that you have here the error. By the way, they have two issues over here. The first one is that, of course, they have an SQL injection vulnerability. But the second one, you can see that the message that's returning to the customer, what you can learn from it, what you can see here.
Well, the language, maybe.
The language you can see, exactly. So I can have information about the technology behind the scene. So again, when I'm able to retrieve error messages and I'm able to analyze what kind of framework they are using, what type of components they are working on, and when I can see the code, I can know how to attack the website. Yes, it uses SQL Server, you're right. Okay, server infrastructure and so on. So if you look deep, for example, you can see that they are using SQL exceptions and so on. You see unclosed quotation mark. So basically, if I add a dashboard on the URL, if I add it on the URL, I can add whatever SQL I want to do, and I can even do a drop to the database, correct? So this is really nice. Now, you said about banner grabbing, and this is the exact term, because we're trying to create an error when we communicate with a certain service. We want to gather this error back. And we do have databases of error messages. For example, we know that SQL Server 2016 versus 2019, you have different error message when it comes even to the caps lock of the capital and the number of spaces and so on. So we can identify the type of technology behind the scenes if we are able to get the information back, okay? Just a second, I'll read it. Client-side definition is also mandatory. Again, I will explain. You can do it, but you need to keep in mind that you cannot really prevent anything that you are getting from the client from being malicious. You cannot protect yourself from the client side. The client is something that's completely under the control of the client. This is why we call it the client side. I agree that we need to add a mechanism on the client side, but again, as far as security from my end, as someone who is hacking into applications, I am telling you, there is nothing that you can do on the client side that can stop me, because that's the whole idea, right? I don't really need the browser. I can have my own tools that are simulating the communications and so on. Okay. Oh, we are going to talk about blacklists and whitelists really soon. Okay.
Nitzan,
yes.
Can you maybe explain how this SQL injection work in this example? Like I have a URL, and if I add some SQL, how to call it, SQL.
So let me explain. Okay. So basically, you see, we have here the parameter in the end. For example, movie 1109. Okay. In SQL, when you add a dash on the top, it tells the SQL that this is closing the string, for example. So you can continue to enter your own SQL commands after that. The whole idea of SQL injection is that somehow input from the user is being used as direct text, and then the SQL that receives this text is basically joining the two strings together and referring to it as a command. If you want, I can show more. That I think that it's second. Let me try to show you. For example, I will try to. I don't know what you're seeing, but I will
why they have this feature on SQL? Like it's very. Should I?
It's not a feature. It's not a feature. I will assume that you can see my notepad, right?
Mm-hmm.
Okay. So I'm doing select. I'm trying to select where user equals Nitzan. Okay. So this is the input that I'm getting from the user, right?
Mm-hmm.
This is the one. Now let's assume that instead of Nitzan, I am writing down this. Okay, and then I want the other question mark will be just, this will change the rest of the sentence to a comma, or to a remark. So I'm copying it down. Okay, let me just copy that. And instead of Nitzan, I want to put all this string. Okay. So you will see that now, when the user is giving me this kind of string, Nitzan dash or 1 equals 1 and so on, you will see that now what happens is that the SQL is basically receiving this command. And this command is always true, right? So if, for example, you have, if for example, here I add and password word equals XXX, even though that it's supposed to be a hash, don't copy that. So again, here in this case, this will be after the remarks, which will never be executed. So technically, you can log in just by knowing my name. So again, the SQL itself is just a technology. The fact that you are using it in the wrong way, the fact that you are taking the input that the user is giving you, and you are referring to it as something that you can actually trust, that's the problem. Okay?
Mm-hmm. Yeah, I was not aware about it. Like I've heard about SQL injection, but now I see what is actually SQL injection. Should I worry if I'm working with Mongo? Should I stick to Mongo always? Because
there is a permission area also, no? You cannot write what you want in here and it will work.
No. It depends if you have input validation. If you have input validation and you have protection against SQL, fine, then you will be all right. If you don't have, like any other technology, if you don't use, then you have a problem. Okay, but like I said, so as for the database, any database is vulnerable in some way. MongoDB has different things, but I want to show you something else. Okay, I want to try to show you something else. So basically, I will take, for example, this kind of customer. I know that you don't see anything. Let me try to see, for example, this thing. Okay, so I want to show you. Okay, so I'm doing a share screen. This is, for example, one of the projects, which is called OWASP Juice Shop, okay? You know Heroku app? Basically, you can create a website which is vulnerable, okay? So here I have an email and I have login, right? So this website, for example, is vulnerable to SQL injection. So I can write down, let's assume that I don't know what is the username, okay? So I'm writing down the same thing. So I hope that in the end, I know specific in this website that they have SQL injection. So I'm putting whatever I want here, okay? This is just a random string. And I'm doing login. And since I have SQL injection flaw inside this website, I am able to log in without even have a user, okay? If I have and again, if you have VWAP, I know we'll talk about it soon. So if you have protection against SQL injection, it will work. Like our OM, exactly, it can protect in some way against SQL injection, but I will have to see how you're using it. But let me just summarize that. If I have a single point where I can have SQL injection, the problem is not entering the application. The problem is how I can download the entire database, because technically I can do select from the entire database. I can download the database as a file, okay? Now, for those of you who will be part of the lab, who wants to be part of the lab, okay? This is exactly what we want to do. We want to take a certain vulnerability and try to pull the information to ourselves, okay? So did that answer the question?
Yes, 100%.
Okay, so the question is, how do I know which websites basically have these kind of vulnerabilities? Let's say I want to hack into a certain website and so on. Swati, I will explain a bit SQL injection more. We have more on that. But basically, just a second, just to refer to what was right in the chat, we will have a lab on injection. So again, we will go more into that over there, okay? So I'll try to explain more, but maybe in the next few slides. So if you want to know which websites have these kind of vulnerabilities, or how hackers are finding the way which websites they can abuse SQL injection, you know which tool is basically giving you that kind of information. Do you know? Do you know which tool gives you a list of websites that you could abuse with SQL injection? Which tool? Yes, no. Oh, SQL map is perfect, but no. Google. Google. You can Google it. You have something which is called dorks. Dorks is basically a search of vulnerabilities, and you have, for example, you can look for cameras that someone connected to his home and just left the default password and so on. So you have Google Docs, and you have Google Docs also for SQL. You can just search, you can have a list of commands that are basically searching for websites that have SQL vulnerabilities. Of course, you have also CVE vulnerabilities, and you also have search engines that can point out that, but basically Google is doing a great job. So you can search Google Docs for almost anything. In the end, after you search Google, we try to slow you down and asking whether you are really a person and so on. But Google Docs is something real. You can Google for vulnerabilities online because Google basically indexing everything. So, so let us continue. All right. So SQL injection is basically, we see that a lot with a lot of affected websites. And again, I do encourage you to come to the lab to try to abuse a website yourself, okay? But we've seen a lot of information, a lot of websites being vulnerable to that, especially when it comes to plugging, like in WooCommerce, on maybe third-party components, because most organizations don't have software bill of materials, and most security teams don't know what kind of components you are actually using. It's very hard to know whether there is a new vulnerability published. You remember that on the last session, I told you that you should have you should have a list of your components, and you should give that list to your security teams because they need to follow. And when someday you will have an SQL injection, for example, vulnerability for one of the components, then they need to help out. They need to warn you, and they need to help you to find a good solution for that. Okay? So questions so far? Okay. So let's try to go deeper. Okay? So in the past, we used to think that the server was a safe zone. And eventually we started discovering that attackers, when they go inside the organizations, they stay something like between 3 months and 190 days. So basically, we all came to the point where we cannot trust anything, even if it's within the network. So when we come to that understanding, we developed what is called Zero Trust Security Model. Zero Trust Security Model assumes that untrusted actors are already inside our networks, which is why we always need to validate. In the past, I don't know how many old people like me you have here, but in the past, we learned something called design by contract. And we assume that when someone is calling us, then he should call us, okay? We assume that we don't need to check the input, or we don't need to do input validation because he's calling us and we are inside the network, so it's definitely secured. But we've come to the point where we've seen bad actors, abusing that thought. So today we say, always validate, and if you can, in your code base for input validation, for different types, for different structures, and so on. Again, this is also coming from best practices in code. We don't want just to copy and reuse code. And in case you have a bug, you need to correct it in 5 different places, okay? All right, so this is about the Zero Trust model, very famous, very known in insurance company and banks and so on. They're all talking about Zero Trust, okay? So if we are talking about, like you said before, about strategies for input validation, we are talking about 2 main strategies. The first one, second, I have your pictures on the text. The first one is, of course, syntactic. I want to make sure that the structure of the date is, or the field is as I expected it, okay? I want to make sure that what I'm getting from the customer is basically the exact type of information that I received, okay? And the second one is semantic. I want to see that the business context of this value is somehow reasonable, right? That the price should be bigger than 0, or that the date should be up to a certain date or before end date and so on. So this is the business logic. So we have the semantic and we have the syntactic and the semantic also between the two. But our main assumptions is that all input that's coming from the user side is evil, okay? And this is why we need to do what we call reject by default. I know it sounds harsh because we want the input from the user, right? But we need to be very suspicious about what we are receiving, because basically input validation is the way for the attacker to get into our networks, right? So here we need to be very suspicious. So this kind of principle said that in the end, and you see the small bugs, this is what telling you that this is a place that I don't trust, okay? So basically, I am doing input rejection if any validation fails. If some of the data is incorrect, then I shouldn't process it. I need to validate before I process anything. I need to check the data that I'm receiving from the customer in the beginning, all the data, and not some of the data in this function, the other function is handling that, so I'll check it over there. We need to do it in the beginning, and if it fails, then we need everything to fail, right? You cannot have half an action that starts, okay? Questions about that? Okay. Okay. So you said before about blacklist and whitelist. By the way, today we say allow list and deny list because of politically correct reason. But okay, but what do we prefer to use? Blacklist or whitelist? Write it down.
Whitelist.
Whitelist, because we cannot blacklist everything. So at least we can whitelist the things that we want to process.
So I want to agree with most of you, and I also want to say something to Paulo, which I also agree with him sometimes. We prefer to have whitelist. We prefer to have allow list. I want to say what I want instead of saying what I don't want. Okay. Now, about the deny list, there are some cases that I really want to create a deny list. For example, in some companies, not most companies, some companies today, for example, they take every year the list of popular passwords. You know, they put them in a table and say, we don't allow this list of passwords. Now, every year you have hundreds of thousands of passwords being breaches and published, and you can see that the most famous password, the #1 password in the world is, the most popular password is not God. Diego, I know. I love God is excellent in. I see admin. They're giving me all the passwords. Yeah, all of these. Yeah. It's 1 to 6. It's 1 to 6. In the States, I love God is very strong. But yes, it's 1 to 6. Still popular. Still very popular. All the QWE, all the keyboards that are closed, all of them are very known. And in most cases, I will want a whitelist. In some cases, like in the case that I gave you, where you don't want your user to do the same issue, Pablo, this is brilliant. Where you have the same issue, then you want to prevent them from trying popular passwords. Because as a hacker, the first password that I'm trying to enter are the popular ones, right? So if you can stop me, if you can see what I'm doing, if you can prevent me from entering or selecting a password that is very common, then you can have a better security, okay? So just to summarize, whitelist or enable list, first deny list. So whitelist, protect against tomorrow's threat, because I'm saying now what I allow and what I don't allow, right? I'm saying I don't need to enable everything that I have, I just need to enable this kind of text that I want, okay? So this is basically the new approach that we have for list, and the backlist is really considered to be more old school, even though that I must say that like in the case you have, sometimes you do have cases where you will use blacklist. Blacklist forces you to have a list of known threats, and that list can be updated daily, okay? So when we say blacklist or deny list, it basically protects you from yesterday's threats. Okay, Alon, thank you for the complete information about how you do passwords. By the way, after 9/11, when a lot of people died, they tried to recover some of the passwords, and this is exactly what they did. They tried to have their pet names and addresses and birthday date and so on. And in most accounts, they were able to find a way to hack in, okay? Okay, so questions so far? Okay, now if you look for best practices, like I said, you have a lot. You have a lot in OWASP, but also in other places. You have cheat sheets, which are very practical. You have SQL injection sheets and so on. You have even a project, for example, like the ASVAS project or the Code Review Core project and so on. We have a lot of projects handling input validation and data security. And again, it's just finding the one that works for you. By the way, inside input validation, you will have also implementation in various of development languages, okay? So it's very nice if you want to find out how to protect yourself. So let's summarize this issue. So the first one is, of course, be paranoid. All input is malicious until proven otherwise, okay? Allow list, we want to tell what we expect to receive and reject anything that doesn't fit over there. Always use server side, always have validation on every tier, every service. I know in some cases we want to save time, but we need really to evaluate the risk, whether this special tier or special service will be used by attacker, okay? And the last one, centralize your validation code. And this is just a practice which is practical also for, good coding practices. Okay, so this is for the input of information, right? Now I want to look at the other side. I want to look at output handling. So the first question that I'm asking you, and you do see the slide, right? Just say yes, you do see the cool with the arrows and so on. Cool, okay. So what is output handling? What is it? Why do I need to care about output handling? I'm just putting the output. Okay, you wanted to have the list of customers. There you go. You wanted to have the report for your, there you go. You can have it. Perfect. Why do I need output handling? Why is it number 2? Okay. Okay, Diego, thanks. More? Only Diego? Match expected response from the API. Okay. Attacks like JavaScript. Oh, now you're getting it. Okay. All right. All right. So
output data can also be modified to get sensitive details like session IDs or cookies.
So you're absolutely right. When I'm giving information out, I need to make sure that first, I'm not giving something that I'm not supposed to do. And second, I have a different assumptions. Tanya, 4 is not probably not an output handling technique, but I will go with that. So we said about input validation that when you have a customer that is sending information, I assume that it could be malicious, right? In the output handling, when I give a different customer or different service information, I work under the assumptions that it could be that someone already hacked my systems. It could be that I am the vulnerable one. It could be that I somehow am doing a mistake and returning too much information, or someone is basically manipulating me into doing something wrong. For example, like an attacker who injected a certain script into my systems, for example, right? So output handling basically makes sure that untrusted data cannot be used, by an attacker to start an attack against our users, or maybe to start an attack on us, okay? If you look, for example, on one of the famous attacks that we have, it's called cross-site scripting. Cross-site scripting is when an attacker injects a script into our website or application or API and so on. And then, of course, you could have several effects to that injection. One of it, for example, if we take this scenario of a news website, let's assume that I have a news website and you have comments below. So let's assume that this attacker is basically injecting a script into the comments. It did happen, right? It did happen, cruel, yeah. It did happen, by the way, in MySpace, we had a user who injected a script into the comments, and that's how he got to 1 million friends. You can Google it. He got to 1 million friends. Basically, what he did in the script is basically taking the cookie and asking for a friend request from his user. So the attacker is basically translating a script or maybe sending a script inside our URL. And then we have a user that is surfing to that website. And when you go into that website, the script is activated. And in some cases, it's creating a connection between the attacker and the user, and connection that we wanted to prevent, right? So again, this is very cool scenario. By the way, up to 4 years, 2/3 of the websites online were vulnerable to some sort of injection of cross-site scripting, at least from the one being tested by OpSWAT. You have a very cool statistics over there. And you do have, for example, a website from Google, which is called Google XSS Game, right? This is a very nice website where you can actually play a game and try to hack into a site which is originally designed to be vulnerable. But by the way, Google have several websites where they encourage you developers to try to hack into specialized websites built in a certain way. For example, like the Courier website by Google, all of them, when you log into the site, you are getting your own session, your own special version of the site, and you can hack it. And again, this is legal. This is legal, and you also have a lot of guides showing you how to attack. And again, the idea behind it is that if you know how to attack the website, then you probably will know later how to protect yourself against. So let me just look at the time. So we will do this for now. We will have a 10 minutes recess. For those of you who don't want the 10 minutes recess, you can play the XSS game, at least for the first level. I will show you how it looks like. And after we return, I will try to show you a bit more of input validation, output handling, and best practices, okay? So 10 minutes. So 10 minutes from now, and let's get back here. Bring a coffee and stay awake. Okay? I'll see you here.
Thank you.
Thank you. Alon, are you sending me malicious links? Second, I'm trying. No, it looks all right. I'm getting the same.
What you getting?
I'm getting the same thing. You don't see oh, you're writing to everybody. Hit this. Okay.
Yeah.
I thought you're writing to me.
No,
okay.
No, sorry.
Thank you, time. Okay. Second.
They're asking what is the game, I understand, Amir.
So the game, if you can try to use
guess what the script is giving us. Some script of frame, the giving alerts. So that's it.
It's giving you an alert, yeah. And if you do all the subjects, you can even get a cake. So second, let me also try something else.
You can change the form and to what you want. Yeah.
Yeah, exactly. Second, there you go. This is Google Gruyere. You do see my screen, right?
Yeah.
So this is Google Gruyere. You have here, you see, you can launch yourself, or you can launch a vulnerable website. You can just access from here. It creates your own session. And you have also about the code, and you also have here, you can see on the side, you have all the type of attacks and explanation how to exploit them, how you can exploit them. This is cross-site scripting, cross-site forgery, different types of script injections, and so on. So this is really nice. Also, you can do denial of service. You can even come to the point where you have administration right and basically delete the website that Google gives you. So this is really brilliant. So you have several websites like this.
Like attacker, yeah.
Yeah, you can play.
Same like attacker, yeah. Nice.
Okay, and until everybody, okay, I'll wait 1 more minute for them. I hope you grab the coffee.
I grabbed the kids.
No, mine are locked. Good luck over there. Oh, yeah. Crazy times, really crazy times.
This time 4, this is the time that they enter to the home.
Oh, well,
yeah.
Mine are a bit bigger, so basically they have their own life, so you're trying to lock them. But yeah, this is a good reason to come to the office. Okay, so I promise to continue on time. Gilat is here. Gilat, I'm with your session. Okay, continue, okay? All right, so just something nice I wanted to show you until everybody returned from the session. This is something called TabiCat. You know what TabiCat's here? You know what it is? TabiCat is, this is the cat. Basically, if I refresh, you see you have different cats inside your browser. Alon, you do see the cats, right?
Yes.
Oh, okay. So TabiCat,
sure.
So TabiCat is basically a company that is selling pets for online. So you can have here, and you can buy different pets. So if you think about career choices, this is really working out because a lot of people are adopting a dog and so on.
It's not related to Tomcat, yes.
It's not related in any way, but they are making a lot of money because people are adopting pets, and you can buy also, you see, you can buy toys or you can buy hats and you can buy different expensive gifts and so on. But what is interesting about this, and again, not because I want to try to sell you pets and so on, you see, the reason why I'm not being asked when I try to choose to change to a different pet, you see here, I have the list of pets that they have, okay? So you see that basically I can choose whatever pet I want, right? If you try to install it, it will ask you to pay for the pets. But if you see, this application is basically keeping all the pets inside the local storage. So you have here this value, and you can just select which pet you want. Right? So this is, for example, why we don't trust the client. Because you can change whatever you want inside the client. I can change it here. I can change the number. And again, this company is working it here. It's using the information which is local on my computer and is trusting it. This is why they are not asking you for money. Okay. So again, just a night until everybody got back. Let's hit it back. Okay, so everybody seen the cats? Good. Okay. And all right, so we have, for those of you who did it in the session, so of course, you just need to use on the first one something like script alert one and script, and over there you can have a pop-up. And if you saw here on the address, you basically have the same link of the website, and you can add the search parameter here. Now let's assume that XSS game is a trusted URL, and I'm sending it to you, and I'm adding my script in the end. So when you look at the URL, it will look like this URL is basically forwarding you to the right location, correct? But basically, I'm abusing a very certain vulnerability of this website that when you open it, it runs my script, and that script can be very malicious, okay? So this is the main weakness that we have with cross-site scripting, okay? So we want, when we output information, we want to take care of our customers, we want to take care of our data consumer. Now, it could be a service, it could be our main customer, it could be anybody that we are communicating with, and we want to guarantee that our vulnerabilities will not put him in danger. And more than that, we want to make sure that we are not exposing ourselves in any way. For example, we will want to limit the amount of data that we are sending back, right? If someone is searching for a list of customers, there is no point to give him 13,000 customers, right? You don't go on the list and you're on the 5,432, you say, this is the person that I wanted to find. No one is working like this, right? So we need to limit what we are sending. We need to prevent attackers from trying to exploit our systems. So the main strategies that we are talking about output handling basically is sanitation, which is transforming the data by encoding it. For example, if you take a script, let's assume that I do want to return a script to the end user. For example, if I have a website that shows scripts like Stack Overflow, I will want to return to the user the output, which includes some sort of scripts. But again, for the browser, I don't need to return it as a simple characters. I can encode it, I can change it in a different way so that for the end users, it will basically look the same. Now, second things, I need to filter down. I need to filter what kind of output I'm expecting to have. I need to filter down what are the criteria that I have for me to extract information from the system. For example, management reports shouldn't be extracted to anyone other than the domain of the organization, right? For example. But my main assumption is that any data that is leaving yes,
are you sharing the presentation?
Yes, we can
really?
see.
We can see only your, your browser with the poofy.
What? No. Now?
No.
I thought we were behind this. Okay, sorry. You're right. I don't know what's happening today. Let me try again. Now?
Just a dark screen.
Started, but no presentation. Yeah,
now we can see.
Oh, brilliant. Sorry, so I'm going very fast. Sorry about that. A crazy day, no idea what's happening to Zoom. So this is the solution that I said when you just have, sorry about that. Let me go back and have the laser, sorry. Here I said that if, for those of you who played with the website, you can see that the script is basically being added here, same as SQL injection. So basically when I'm sending the whole link to the user, the script will be activated, same as it worked for you. So basically you were able to do cross-site scripting. This is the second one that I said, that we need to protect our data consumer, customers, and so on, to avoid unintended interpretation or to avoid us sending too much information. And this is the last one. Just let me know that you see the big shield in the middle with the two wings. Very impressive. Do you see it?
The output handling?
Yes, output handling strategies.
can see.
Oh,
Yes.
perfect. Okay, so
I don't understand what you mean, but okay.
it's very impressive. Come on. Okay, so like I said, we have two things. We have the sanitation, which is basically
The shield one, you can say. Okay.
What, Alon?
The shield, you mean?
Ah,
okay.
the shield. Yes, exactly.
Yeah, yeah.
The shield is impressive. Okay, you're right. So basically, like I said, we want to change the code, the data that we are sending, and changing it to a different structure that couldn't damage our customers, and we want to filter it out. Our assumption is that any location outside of our control is something that we need to handle by using output handling strategies. Okay. So again, if you have output that you are taking out of your systems, you need to make sure that you are not damaging the other side. Just try to think about in a different way that in this point, we are the side that could affect our customers and not the other way around. Okay, so we talked about input validation and we talked about output handling. Next one I want to talk about is access control. And access control is basically the summary of all security. Because if I can manage access control, I can finish everything that is talked about security, and I can make sure that my applications are secured. So access control is basically granting or denying access. It's not the same as authentication, which is to verify who is talking to me, right? So I want to make sure who is accessing what. I want to make sure in the beginning of the process, when someone is trying to reach out to a resource, as he's trying to reach out to that, we want to stop him or allow him, depends on his roles or depends on the way that I want to support him or not. Now, same as input validation, we have also attackers that are trying to use certain mechanism in order to attack our end users. I want to show you a sample. This is a real sample from a customer that agreed to share it, but I want to show you an Excel injection. I know that some of you may not heard about Excel injection. Maybe some of you even recognize the application. It's in Hebrew, I know, but let me show you what is happening here. You have here a place where the customer is entering a string. And you can see what was entered, a command line, and then some sort of command. When you open Excel, I don't know if some of you know, the Excel will try to run whatever he has inside the Excel. Now, if you are not preventing macros and so on, so this command will work. Now, when you inject that, this was just the first part of the attack. The attacker basically injected commands into the Excel. The second part is that when the system automatically created Excels and sent to the customers, the command just worked and started being activated. For example, in this case, in the scenario that I showed, the Excel actually opened the calculator. Do you see it?
Yes.
You're impressed, right? Very impressed.
Yes.
Okay, so this is a really nice attack. That's something that we allowed in one point is basically returning to our customers on the other end. And again, this is something very simple. And if it wasn't something visual that the user could have seen, then this could be used to attack the end customers. Now, again, when it comes to access control or when it comes to bypassing, our assumption is if there is a way to bypass your access mechanism, people will probably find a way. If you are trying to limit your attackers, if you're not, for example, limiting the hit rate and so on, if you're not looking about who is doing what, then you are probably vulnerable. The same system, one of our customers wanted to limit the number of files that are being uploaded. So he put a block of 10 megabytes. You could have uploaded only 10 megabytes. And he said, I have a physical disk of 300 gigabytes. How many files do you need to upload? Well, guess what? Attackers did. They uploaded files, 10 mega files, and they uploaded a lot of files. And in the end, they were able to block completely the server. Now, again, when we talk about access control, what we allow, which resources we allow to use and which are not, we need to know that these could be exploited, by attackers to find a way in. Because this is exactly the kind of special thinking that I'm calling the hacker mindset. This is what I said in the beginning. we can prevent our user from entering files up to 1 megabyte. But I think the smart way would be to say, you know what? A customer can upload up to 100 files a day. I don't see any reason why we do more than that. And if he needs more than that, then I need to find maybe something to alert that I have lack of disk space, for example, okay? So if I want to talk about what is access control, maybe it's easier to talk about broken access control. What can break our access control? So the first one is, of course, for restrictions. Are you not putting enough restrictions on what you're allowed and not allowed to do? The second one is, what are we putting on the client side caching? What kind of information we have on the client that could be manipulated and changed against us? And the third one is, of course, our users. And here we have a very sensitive problem. Again, when I say power users, I'm not just referring to users, I'm referring also to users that belong to services. Certain services that get too much permissions to operate. When you develop an application, of course, you know that you need a certain level of permission to operate, right? When you have a service, you need to give it a certain level of operation. And we, from our side, when we look about all developments, in the time it used to be administrator. I'm sure that some of you worked in the past and you remember that we added the username as administrator, and we had power users, and we even had services that communicated with the database as system admin. So basically, this type of service was able also to delete the database or drop it and so on. So again, the idea of access control is how we can limit the access rights that the user have, how we can add more restrictions, and how we can not trust, for sources like the client side. Okay, questions so far? Are you good?
Okay.
Okay, all right. So let's continue. One of the comments over here, Nir, you said Puffy, and I don't know. Only the bear, the Puffy. Okay, now I got it. Someone said BWAP before. I don't know if most of you understand the comment, but BWAP is exactly a good point. BWAP is basically an extremely buggy web application. It's a website that you can install on a local Linux and so on, and you can try to exploit it. And one of the few games, we have a lot of games here over there, and one of the interesting things that we have over there is you can set the level of security of that website. So you can try to hack the service in different levels of security. And I can tell you that even in the highest level, if you have a security vulnerability, then the hackers can go in. It doesn't matter if your website is very highly secure, okay? So for example, in the low phase, in the low run, we see applications that are adding parameters on the top here, like admin equals 0, you see? So again, here, the user can manipulate that and take it to his advantage. If you change the security level into a bit higher, then yes, it will not be in the URL, but definitely you can see it. You can see it in the body of the request. You can see it in the GET request. You can see it here. And you can also change that. And again, hiding a parameter, hiding something inside the environment is not really a good way to protect ourselves. You cannot accept something to be disabled or hidden from the attacker, and that will be our defense. One of the companies in Israel, when we went through the website, which was completely insecure, we asked what was their security, what are they doing for security? And then they showed us that the main application that they had a special URL, which is consisted from random numbers and characters. That was really nice, except Google indexed that. So basically everything was exposed. So it's not really a good mechanism, okay? So if I want to summarize access control until this one, if I want to make sure as far as implementation, again, you need to enforce all requests through a central place where you manage access control. And again, this is the same thing as I said about input validation. You need to deny by default. You need to give permissions, the minimum that you need in order for that service to operate, okay? Avoid hard-coded access control checks. Avoid these. This is all-time security coding that we used to do. We had a function, we used to check if that user belonged to group admin or that user, no, avoid that. Try to have a smarter mechanism to use use on your application. And of course, service side, I already said enough that. And now I want to talk about authorization and authentication. So these two I want to talk about a little bit more. So the first question to you is, what is the difference between identity, authentication, and authorization? Between these three, what is the difference?
I think authorization is more about permissions.
You're right.
Authentication is about me being a valid user, so I can log in.
You're right.
In the first place. And identity, I'm not sure.
Identity, you got most of it correct. Identity is what the user is claiming to be. So I'm giving my username or email. I'm not proving it in any way. Proving it is authentication. I'm giving some sort of, just a second. I'm giving some sort of, so who I am? Oh, you're right. So who are you? Can you prove it? What can you do? Okay. So basically, I have something which is the identity of the user. That is mostly something which is public. For example, the username. I can assume that username and email and so on, they are public knowledge. Even ID is public knowledge, right? Now, in order to do authentication, I need to have some sort of secret response. It could be constructed from several secret responses and so on. And authorization is basically, what can I do with that? What access control am I giving him? Now, when you talk about these three, it looks simple. But when we look at the breaches that we had in this specific field, they are very interesting. For example, we had these, the Zoom just blacked out. So for example, Ola Cabs. You know Ola Cabs? Any one of the participants here? Anyone?
Like Mexico?
Ola is in India.
India,
Ola Cabs is in India, India's largest startup. Really, they had a lot of money gathered, 1.1 billion. And basically, they allowed you to order cabs in India. So the problem is that hackers were able to use man in the middle, and they saw the API calls that are basically going through HTTP. So they were non-encrypted. More than that, there was no token or encryption in place. There was nothing to guard as far as security from the API authentication and authorization. So they had a very, let's just say, a nice breach where you can basically order yourself a taxi without paying, okay? So again, this is a very nice case where you can see that when you don't check for access controls, hackers can manipulate that. By the way, as far as we are talking about input validation on the client side, this is, for example, Tinder, okay? Tinder, for example, on their mobile app, we have that you need to swipe right, I think, to approve someone and swap left, not to approve. I'm sorry, I'm not a Tinder user, so it will be a bit harder for me. But the issues that they had, if you want to swipe more, you need to be a premium user because on the free version, there is a certain limit to how much you can do it. So hackers took the Tinder application, they did reverse engineering, and what they did is basically allowing you to swipe more to the right. Now, Tinder, of course, said that it's not really that much of a breach. Same thing as Ola Cabs, right? So we had a few users that were able to approve more girls. Fine, we can live with that. But again, in the end, it all comes to, do we understand the threats that we have by doing or not doing certain things to our application security? Okay? All right. So the goals that we have to identify the users, the goal that we want to authenticate the users is basically constructed from these three. We want first to deny access to anyone who is not supposed to be there. All right, this is the main thing that we want to do. We want to have authentication controls, and we want to manage somehow the user credentials. If you remember the first session when I talked about Salt and Pepper and Ashley Madison and so on. So again, when you have credentials, you want to keep them because the attackers wants to receive them in any way. So if you look, and this is, by the way, the next slide is exactly the slide about the passwords, about the common passwords that we have. So the list that we have today is basically belong to 2020. And again, you see that people are doing the same mistake over and over again. 12346 is a very common password that is being used until today, since the day I started having these kind of sessions, okay? So it's not that complex, not that complicated. So like I said, the easiest thing will be to do a blacklist, prevent your users from creating a password that is too weak, okay? Questions so far? Going too fast, too slow? Okay, all right. So I want to talk about passwords. So the questions I'm getting a lot, how strong should be my password? Okay, what to use in applications. So we do have instructions when it comes to passwords. For example, NIST created a list of how short or long a password should be, and they actually created a plan also for years to come, assuming that the power of computing will increase. So today we are talking about 10 characters, which are weak. So we're talking about 12 characters, according to NIST, 12 characters for a password. This is what also the governments are asking for users, 12 characters. And if we are talking about services, it is better to use 16 characters even, because services can have a complex password. It is best to use complex password. Of course, the password shouldn't be based on similar password before or close to history of password and so on. We also should support change of passwords, even to services that are basically shouldn't change. This is, by the way, one of the problems that people that in the application industry, in the development industry, we don't change the password for services, right? Because it's basically a headache. But this is something that we should do. Maybe not as a human users, not every 3 months, but definitely every 6 months. So 1 year, we should do that. Next, we should have multi-factor authentication where needed. If you are looking at certain regulations, like for example, the Singapore regulations, this is becoming a standard to have a multi-factor authentication per systems. And the last one, we should be aware that attackers are also trying to manipulate the password recovery and the password reset button and so on.
Facebook, yeah. Facebook
for example. All right. Okay. So again, this is for me closes the issue of password, and I want to move forward to something else that we talked about on the last session, which is basically the use of components. Okay. Second. Sorry. This is what having kids home. Okay. So again, last session we talked about components. I want to take a deep dive about the components that you are using in your application. Okay. So again, the first one is using open source analysis. Now we know that 95% of applications today use open source components. It's becoming very clear that open source is something that we want to use in our application. And again, they bring certain richness to our environment, and we can have much faster development, okay? And it's very common to have one. But we also know that 67% of applications that have source code are basically having also vulnerabilities. This is exactly why you have, for example, this story, which was originated from a certain flaw in an open source component, allowing credit card exposure, okay? Massively credit card exposure. So the question that I have is, what is important to us? And I want you just to write down, when I use a component, what is important for me to know? Okay, so if you could just write down, what is important for you when you choose a certain component to work with? That's my question. License version, perfect, you're right. We'll talk about that soon. More. That's it. So I'll explain the license version. You have different types of license, for example. We have license in open source that ask you to distribute your source code, and you know that license of open source can also change, right? A good AV info, all right. Activity, number of commitment, okay, Gilad, you're perfect, you're right. Okay, so we want to analyze which open source component we are using, right? That's what we want to do. We want to make sure that we are using not just a component that is good for the purpose that we want, and not just to have a security issues, right? Because that's the first thing that pops out, right? You're looking for a security problem, but not always, right? So I'm looking for 4 things, basically. I'm looking to see whether this special component is popular. I want to know if it's maintained. I want to know if there is a community. And I want to know if there is a security issues. Now, I'll tell you something that most tools of open source don't really know how to test these kind of things, unfortunately, right? But you do have open source tools like this one, open tools like Snyk Open Source Advisors, that basically give you these parameters. Now, even if you don't use these tools, you need to be aware of that. For open source, I'm looking for activity. I want to see that the component that I'm using is not dead. I want to see that I have a community of people that are communicating and publishing information. I want to see that this component is important enough to be investigated and look for, weaknesses in design, flaws, and security issues and that. And of course, more than this, I want to be able for my security team to follow that. So I want to tell them that I'm using this type of version 17.1 with this component. And if I do all that, and I'm sure that I have a good component, and the organization is telling you which kind of mark underneath you are not supposed to use that component, then we can have good practices when it comes to software components, right? So of course we have open source components, but we could have also commercial components that will also have vulnerabilities, right? We've seen it on the last session when we talked about vulnerabilities. I showed you that you have CVE databases that basically show you what kind of vulnerabilities you have for each component. So if I want to talk about best practices on how to prevent that, I will start from the basics. The first thing is move what you don't need. Remove components that you don't use. Sometimes we copy from one project to another, a certain infrastructure, for example, or we copy things that we used to have, but we don't use them today. So I'm saying you need to overview your project and you need to know which dependencies you don't need and you need to kick them out. Anything that you are using which is unnecessary, then you are opening yourself to new vulnerabilities. Okay? Next one, you should have a list. You should have a list of components that you're using, give it to the security team, and they will follow it. Use official sources, try to work the way that you're supposed to have, and of course, monitor them. I always say in red, hug your security department. Again, it's their job, and they're supposed to help you with that. When we talk about tools, I do want to talk about tools a little bit. We talk about several types of tools. The first one, we call it static application security. Static code, or SAST, static application security testing, is basically tools that combined with your development environment. They give you comments on your code. So you can get live input when you write down your code. The second one is called dynamic application security. By the way, we will use such tool. You also have free tool called ZAP Attack Proxy from OWASP. It's a free tool, which is one of the free tools recommended by Microsoft to check your environment. But again, it's a tool that is checking the product as a product and not necessarily the code. So basically, on static application security testing, you need to have a tool which is working with your development language. But on dynamic application security, you have a tool which is basically trying to analyze the environment and also attack your application. We also have interactive testing, which are tools that are doing both ways. I must say that you don't have a lot of tools that are doing both things in a good way, because it's usually specialty, okay? All right, and of course, we have the open source vulnerability management. We have tools that are specializing in the open source world, like Black Duck, Snyk, JFrog, and so on. And of course, the last one, and we already talked about, is fuzzing. Fuzzing are basically tools that just overload your applications with tons of information, and you should be very careful about what you're doing or not. So again, this is as far as access control. So do you have any questions so far? Okay, very quiet. I know that I stopped the sharing. Don't. But Pablo, can you explain what you wrote? Pablo? No? All right. Okay. So if you want. Okay, that was scary. Sorry, can you see the presentation?
No.
Now? And now?
Now,
Yes.
yes.
I'm having heart attacks today. I mean, I have no idea what's going on.
We are being attacked.
We are being attacked. Okay, so next, I want to talk about loggings. Okay, so like I said, we want to log and monitor our activity. We have a lot of things that we want to log, right? So we have our input validations. We want to log violations and unacceptable inputs and so on. Someone that is using invalid parameters or hit rate and so on. We want also to have output validation in case something in our testing in the output that we have, if we know that we are supposed to return back no more than 1,000 rows and we have more, we want to have some sort of monitor over that. And if we have someone which is trying to abuse our output validation, we also want to know. Of course, special cases and so on, I think that logging makes much more sense when we talk about access control. The idea is not to log everything. It doesn't make sense to log everything. We want to log what is important. We want to try to understand. Second, Pablo, I will go into that link soon. So we want to try to understand how the log could help us. Now, in some companies, they are basically taking tables and putting the log inside the table, you know, in one of the databases and so on. And in the end, after a few years, you have a lot of tables holding a lot of logs and no one really knows where and how to use it. So again, the idea is to log smartly. If you're able to do it in a smart way and not just skip everything, then you can maybe identify and you can maybe do a better job at identifying application errors or high risk issues or even violations in input validations and so on. Other than that, I will add that some of the legal and regulations are requiring you to log. So definitely it's something that should be done, okay? But let me just ask on the other side, what you should not log. And while you look at while you write down, I will look at the link that Pablo sent. Okay. All right. And I also have the link that Pablo said. Okay, now I got it, Pablo. Thank you. I'll say that in a second. Okay. So again, so what's not to? Of course, you write it down. So we don't want, like I said, we don't want to keep in log things that are sensitive, like talking sensitive user information, passwords, anything that is illegal to collect, anything like connection strings, authentication password, sensitive data of our users and so on. I don't want to collect it. When we teach hackers how to hack into applications, this is the exact place we tell them to look for. Look for changes, look for log files, look for anything that the application is trying to write to a site, text files and so on, okay? So again, it's very important to know how not to expose yourself, okay? Now I want to share what Pablo sent us, okay? And again, thanks for the link. Tell me when you see the website.
Yes.
Okay, perfect. So again, this is the CVE. I showed this website also in the image in the last class. And again, this is where you have vulnerabilities on libraries, even on Python, and official libraries also, commercial libraries also. And here you can have the type of vulnerability. For example, you can see that this one is cross-site scripting, and this one is bypass. So basically you have vulnerabilities, published vulnerabilities, like executing code, overflow, and so on. This is DOS. So you have this type of vulnerabilities going every day. What I wanted to say is I don't expect you to go into CVE and browse on your weekends and so on. The idea is that if you are using, for example, you see Python versions before this type, you see before 3.9.3. If you are using a specific version and the security teams know that you are using this version, they will monitor for this kind of alert, and they will come to you and saying, look, we have a new vulnerability. We found that this Python version you have, when you, so it's definitely vulnerable. Let's see whether it's connected to us. Let's see if we need to resolve it. Let's see what's the problem over here. Let's see what attackers were able to do with that, okay? And it could be that this vulnerability is not related to us. It could be that even that we have this Python version, that other mechanism in our software is basically making it immune to this kind of attack. But it could be that not, right? So this is why we need to create the list. If you remember the software bill of materials, this is why we need to have an inventory of our different components. Okay, so thanks for that. And I want to go back to the presentation. So let me just tell me that you see the nice soldier, toy soldier.
Yes.
Perfect. Okay. So if we're looking for the secure development lifecycle, where should we have security?
All the phases.
Oh, you're saying that was an easy one. Okay, okay. Everywhere. Okay. You see, I have a very excellent graphic here. You see that? That was, you see? Insane, right? This is Pixar style. So everywhere, in every phase, we have things that we need to work on. Now, I remember that I told you that Microsoft created the security development lifecycle back before Vista. And basically they said that these are the phases they are going. I'm not going into the security development lifecycle, don't worry about that. I just wanted to say that other than the usual phases that you have in security development, they added two important phases that I just want us to talk about. The first one is training, which is what the organization is trying to do, which is wonderful. The basic idea is if we have better people that try to understand how to do their job better, then definitely we will have better security. And the last one is response. Response means that if something bad happens, I definitely want to be able to roll back. I want to roll back. I want to be able to handle if something is bad with the version or something is happening. How do I respond to a problem with the last version? And if you remember Facebook from a week and a half ago, when they had an issue with the misconfiguration, they didn't have a response. That was exactly the problem. Now, we're not going over there because we don't have time. So sorry about that. But let's try to talk about the different things that we have also for Microsoft. And I want to show you, just to show you, to have a quick brief, because we do have something like 15, 20 minutes. So I just want to have a quick brief about how you can use the different tools in the different security development lifecycle. So the first one, like I said, and I showed you, the first one, like I said, is the training. Training means to teach people how to have secure design, how to do threat modeling. We talked a little bit about that in the beginning, how to have secure coding, how to have testing, and of course, how to have privacy. How do we have to have secured, right? I think there is a delay when you change the slide. Do you see the slide of the people with the pop-ups now?
Yes.
Yes.
Perfect, thank you. Changing slide, sorry. Okay, so this is, I showed it in the beginning, this is OWASP ASPAS, for example, OWASP Application Security Verification Standard, which is a very nice 78 pages right now, with a lot of highlights and really instructions on how we should build a secured environment, right? So it's talking about secured coding and it's talking about secured coding. I really recommend you can download it in Word and you can edit it. Of course, you can also read in OWASP for every link and every section. You can also expand it and learn more about it, okay? So we also have that. Also, if you want to train and try to play with it, I showed the Juice Shop. I showed it to you. And Juice Shop is basically a project written in Angular, and it's a wonderful project. It's a project which is supported by 152 developers. So it's always been updated. So you can try to hack it, like hack the box, trying to teach yourself how to make applications more vulnerable. And if you know how to act, the basic idea is that you know how to protect yourself because you can predict what attackers will try to do, okay? Next, of course, we have the SDLC, but not a lot of people know that unlike the security development lifecycle, we also have a STLC, secure testing lifecycle, which is really important, right? Because we need to know how to test our applications. Again, this is something else. You need to know that it exists and you can use that, okay? So questions so far? Questions? Okay, all right. So I know I stopped presentation second. I just hope it doesn't crash the Zoom. I just want to skip some things and we can go with it. Okay. So first of all, I just want to let's just say that this day was challenging. Can you see the big man which is pushing a rock to the side?
Yes.
Yes.
Oh, I think we can stop here. Okay, really, thank you for your patience today, really. So the big question is how we can provide assurance that our application is basically secured, okay? And the answer is, of course, staying in secured application and becoming better developers. This is what I wanted you to learn from these 4-hour sessions that we had in total. I genuinely believe that your job as developers is to build a better product, a better application. And today, when you talk about methodologies that are being driven by Facebook, Google, and all the commercial companies, and also combined with governments, regulations, and so on, and standards, all of them are saying that application security is directly related to quality. So it's not about making a secured product, it's about making a better product, okay? Now you need to remember that it's not about how big you are, because we've seen a lot of breaches in Facebook, Microsoft, and all the big ones in Google and so on. So we've seen a lot of breaches over there. No one is perfect. It's not how big you are. You just need to find one small vulnerabilities. And again, if you look at the biggest breaches of all time, you can see all the big companies over there. You can see all of them. Of course, taking the top is Yahoo with 3 billion users, which is really something huge. But again, no one is perfect, and even if you're big, it doesn't mean that. Okay, you need to be aware that the smallest flaw in your design can create a catastrophe. By the way, this is just a bad design, right? I mean, if you create a Death Star, the first thing that you need to do is not put a place where you could just destroy it in one. Never mind. Okay, leave it. All right. So, Gilad, I'm getting to the registration. So this is, by the way, this is the topic of the next presentation. So again, I'm getting to the lab soon, Gilad. So again, if you have a source code quality problem, you have a security problem. So you need to change the way that you think. And just to be clear, I believe that it's your job. There, you see, it's not blurred. It's your job. And you need to become part of the solution and not part of the problem. We are trying to move together to make a process where we teach our people to become better. We changes the processes that we develop applications. And of course, we need technologies. We need to be a better developers. We need to have the right tools. in order to do our work. I know that your company is going that directions, and they are doing a wonderful job and a wonderful idea, and they are putting a lot of efforts into that in order to make your development better. And it's really nice because everything that is relating to security is not going to change. I mean, when you look, for example, these are a list of all the attacks that you have. I know that it's moving, so you have a lot of them, and this is evolving every day as new attacks are being recognized. And of course, if you look also at, for example, at publications that you have, for example, on the right here. I'm sorry that it's in Hebrew, but you can identify that. You see that is a vulnerability. And you can see publications from WhatsApp, Facebook, and so on that they are reacting to this. So we see companies that are basically building themselves and reacting to vulnerabilities. So this world exists. It will not change, right? And you need to be an important part of that. Security, if you remember, I said it on the last time, is basically a mindset. It's about not fixing problem. It's about fixing the process. The better the process, the better the software. Not about writing code, but the process of writing code. So I hope that message came through to you. And my message to you is really to get involved. Call to action, stay in the SSDLC, also try to push to whatever you can do it. And that's it. And the last one is stay secured, okay? So that's it for today for us. On the link, second, no, I'm not going anymore. Second, just on the link you have Gilad sending you, to those of you who want to register to a small lab where we will show you how you can attack a website and basically download its content, how you can exploit vulnerabilities and so on. So those of you who want that, so you can have the registration here. I am Nitzan Levy, you have my details, and also Gilad can send it to you. If you need anything, just let me know. Thank you for being with me. Now I'm finished.
Thank
Thank
you.
you.
Thank you.
Bye.
Thank you.
Thank you.
Bye.
Thank you very much.
Bye, everyone.
Bye.
Thank you. Bye.
Bye.
Bye bye.
Thank you.
Bye.